Hey guys, just wanted to discuss one aspect of chromatography, to be more specific, thin layer chromatography. This is something that is relevant particularly when you're doing experiments in chemistry, which is referred to as the RF factor. Some textbooks refer to it as the relative factor, but now we call it the retardation factor. So that's a very important aspect when you're conducting experiments, particularly with chromatography, because in your discussions or in your data, you'll be discussing what retardation factor is or RF factor is. So it's basically a ratio, which is a distance traveled by the solute over your distance traveled by solvent. In my next video, I'll give you an example of a calculation on how to work out relative RF factors of different dyes. So let's say, for example, you've got black dye and you're going to separate it into its components, all right? And you want to calculate the RF factors for each. So think of it like this. You've got concepts like polarity, all right? And what happens in this situation is that you've got the solvent that facilitates the movement of these components of your dye, and the further they move up, basically what's happening is they're becoming more non-polar. The competition here is for bonding spots closer to where the initiation of your dye is. So the closer they are, it's more polar. The further they are, they're a bit more non-polar. So logically, when you're calculating the ratio, which is your RF factor, the distance traveled by a solute of a certain dye over the total distance of your solvent, the higher the number, the more non-porous, or should I say non-polar it is. It's traveling a bit more further. So this is really important, particularly when you're conducting experiments and you want to compare the components of black dye in this case to its respective components. Each dye itself will have a different RF factor. So if, let's say, you've got a black dye, it's split into 4 small components, you're going to get 4 different RF factors. The higher the components, the more RF factors that you're going to be working on. So the first thing you need to consider when you're looking at the RF factor is what's the distance from the piece of paper which facilitates the reaction from where it is to going top to the solvent front. That's going to be your total distance. That's going to be the distance by the solvent. The solvent could be anything like distilled water, 1% sodium chloride, could be acetone. It could be any substance that facilitates the chromatography process, all right? And the distance traveled by the solute, which is the dye that splits from one point to the other. In the next video, I'm actually going to explain to you RF factor, how it's calculated. So in that way, we're able to understand how it's worked and how the calculation process works on. So stay tuned for the next one.